So here in today's lecture, we are going to see this new point, that is hydrostatic forces acting on the surface. So this hydrostatic here, we are going to find out the total pressure force acting on the horizontal plane surface, vertical plane surface, then inclined plane surface, and curved surface. These are the different conditions that we are going to see in this particular topic. And what is the meaning of total pressure, that we should know. Then what is center of pressure, that we will first understand, and then we will see the derivations for these different surfaces here that have been mentioned here. Okay. Uh, Actually, in hydrostatics, the shear force or the viscosity does not act there because there is a no motion. So viscous force is negligible, or you can say it can be considered zero. And as viscosity is not there, there will not be shear stress in the liquid because there is a no motion. And as there is a no motion, there will not be velocity profile. And as this value will become zero, then the shear stress tau is equal to mu into dy by dy. That will also become zero. Okay, so that's why shear stress. This question will be asked in your university examination. In hydrostatic fluid, if the fluid is in rest condition, what is the value of viscosity or shear stress? So that your answer should be zero. Okay. Then what are the various forces will be acting in the fluid when it is in rest condition? The first force is due to the pressure of the fluid normal to the surface and due to the gravity. So the hydrostatic force and the gravity force, these are the two forces, they will act on the fluid when it is in rest condition. So what is the meaning of total pressure? Actually, total pressure force, this word is misnomer. So here actually it is the force. Total pressure, instead of that it should be written as a total pressure force, but in many authors, many books, author they write their total pressure like that. Okay, instead of writing total pressure force. So what is the meaning of total pressure? So total pressure is defined as the force. You can see here they are telling about the force as the force exerted by the static fluid on the surface, either plane or curved, when the fluid comes in contact with the surface. So any surface, when it comes in contact with any fluid at rest condition, then that liquid or that fluid, it is going to exert the pressure on exert the force on the surrounding surface. Okay, so that force which is exerted by the static fluid on the surface. Okay, so that force is called as the total pressure. And what is the center of pressure? It is defined as the point of application of the total pressure on the surface. As you have studied that point of application, force has various characteristics, like force has the magnitude, force has the uh, direction, then force has the point of application. Okay, so this center of pressure is nothing but it is the point of application of the total pressure on the surface. Okay, there are four cases of submerged surface on which the total pressure, force, and center of pressure is to be determined, and we are going to see it one by one, the derivation of all these different conditions in coming lectures. First of all, we will see here the first point, that is vertical plane surface submerged in the liquid. If the vertical surface is submerged in the liquid, then what will be the magnitude of the total pressure force acting on that surface, vertical surface? For that purpose, here we have to consider the fluid element here. Consider this is the vertical surface submerged in the liquid. And for derivation purpose, what we have to do? We have to consider a small strip here. Okay, small strip, we consider the elemental strip, uh, which is at distance h, small h. Okay, this G is nothing but it is the center of gravity of the plane surface. P is nothing but center of pressure. Okay, then H star and H bar. H bar is nothing but it is the distance of center of gravity from the free liquid surface, and this H star is nothing but it is the distance of the center of pressure from the free liquid surface. Okay, then we have considered the small strip which is having thickness dh. So before stating any derivation, we should know all these things here. This small b is the length of this particular strip. Now, first of all, we will derive the equation for total pressure, and then we will derive the equation for the center of pressure. Okay. Total pressure force on surface may be determined by dividing the entire surface into a number of small parallel strips. So suppose here for derivation purpose, what we have to do, we have divided this entire surface into small strip like this. So out of that different strips, we have considered this strip for the derivation purpose. The force on the small strip is then calculated, and total pressure force on the whole area is calculated by integrating the force on the small strip. Now here, what is the logic that is used in this derivation? त्या derivation मध्ये काय logic वापरलेलं आहे किंवा काय concept वापरलेलं आहे? First of all, we have to divide this entire surface into small strip. छोट्या छोट्या strip मध्ये याला divide करायचं आहे. And we find what is the total pressure force acting on a small strip. एका strip वरती किती total pressure force act होतो तो आपण त्या ठिकाणी काढून घेतो. आणि तो काढल्यानंतर what we do the integration of that force to get the total pressure force acting on the entire surface. सगळ्याच surface वरती ऍक्ट होणारा टोटल प्रेशर फोर्स आपण नंतर काढतो by doing integration. Now here let us find out what is the total pressure force acting on the small strip. छोट्या strip वरती किती total pressure force act होतोय तो आपण अगोदर काढूयात. ठीक आहे. आता आपण ही जर या ठिकाणी स्ट्रीप बघितली, इट इज ऍट द डिस्टन्स ऑफ एच. सो वी नो दॅट
आवाज ब्रेक होतोय सर.
नेटवर्कचा थोडा इश्यू आहे. ओके, आता हा एच ऍट डिस्टन्स, ही जी स्ट्रीप आहे ह्या स्ट्रीपच्या ठिकाणी प्रेशर इंटेन्सिटी किती असेल? आपण हायड्रोस्टॅटिक लॉ शिकलाय, हायड्रोस्टॅटिक लॉ ऑफ फोर्स. P is equal to, pressure intensity is given as P is equal to gamma h, right? Small p is equal to P gamma into h. So this pressure intensity is acting at this particular point. Then what is the pressure force acting there? Pressure force किती असेल त्या ठिकाणी? We have to multiply the pressure intensity by area. ह्या स्ट्रीपच्या एरियाने आपल्याला त्या ठिकाणी मल्टिप्लाय करावं लागेल. Now here you can see dp is the pressure intensity acting on that small strip. Okay, total pressure force on the strip, total pressure force जर काढत असेल तर काय करावं लागेल? This d capital P is equal to pressure intensity into area of the strip. त्याला स्ट्रीपच्या एरियाने मल्टिप्लाय करावं लागेल प्रेशर इंटेन्सिटीला to get the pressure force. So this pressure force dp is equal to, pressure intensity is nothing but gamma h. So dp is equal to gamma h into dA. Okay, d is the area of the strip. Now this is our equation number 1. Then total pressure on the whole area is obtained by integrating equation 1. So this dp is nothing but it is the total pressure force acting on a small strip. Now I wanted to find out what is the total pressure force acting on the whole area. Then what I will do, I will do the integration of the equation number 1. Equation number 1 से मैं यहाँ टेकन integration करें. Then doing the integration on both sides, dp will become p. dp से integration का p. Okay. Then I have used the integration sign here. Now here is gamma is constant. It will I will take it outside the integration sign, and this is the integration of hda. Now if you look at this hda is nothing but it is the vertical distance multiplied by the cross section, that area of the strip's area, and this is nothing but it is the moment of the area. hda is nothing but it is the moment of the area about the free liquid surface. So this is nothing but it is the moment of area about moment of that area of small strip about that free liquid surface. Okay, now when I am doing the integration of it, so it is nothing but it is the moment of area of all the strips, that we can say it is the moment of area of the entire vertical surface about that surface of the liquid. Okay, so instead of this integration HdA, I can write here the moment of whole area in terms of moment of whole area. What is the whole area? It is capital A is the whole area. So what will be the moment of whole the area about this particular uh, surface? So A into H. Now here we have to write here it is the perpendicular distance of the CZ. Okay, so what is the perpendicular distance of the CZ from the liquid surface? It is the H bar. Okay, so now instead of writing this thing, instead of that I can write here HA A into H bar. Okay. So here we get this final equation P is equal to gamma A H bar. Okay, where H bar is the distance of CZ from the free surface. Then so we have to remember this equation P is equal to gamma A H bar. This is the equation which we use for finding what is the total pressure force acting on that vertical plane surface submerged in the liquid. Center of pressure, we will see the equation for this now. Center of pressure is calculated by using principle of moments. We state that moment of resultant force about an axis is equal to the sum of the moments of component about the same axis. So we have studied this principle of moment in the mechanics. Principle of moments in the mechanics, we have studied that. What is the meaning of this? Suppose there are different forces acting on one particular structural component, let us say beam. Okay, these are the different three forces which are acting there. Now here, if you want to find out what is the moment about this point, so we need to find out these distances, distance here, then from this distance and this distance we should know. Okay, then the moment is nothing but it is the distance force into this perpendicular distance about this point. Okay, about this point we are finding the moment. Now the moment of this particular force F1, if you consider this is the F1, this force is F2, and this force F3, their moment about this point will be noted as M1, M2, and M3. Okay, that is moment of force F1, F2, and F3. M1 can be written as F1 multiplied by X1. X1 is the distance between these two. Then here F2, X2, here F3, X3, right? So in this way we can find out the moment. So what this principle of moment says. Now if you see here, the resultant of these three forces will be somewhere here, or you can look at somewhere, and it is denoted by letter R. Then the moment of this resultant, it is given by the distance x. Okay, then moment capital M is the moment of the resultant, which can be given as R into x. Okay, this is the moment of this resultant. So according to this principle, this capital M moment of the resultant about this point will be the summation of these three moments, that is M1 plus M2 plus M3. So this principle we have to use for finding the center of pressure. Okay. The resultant force P is acting at point C at distance h star from free surface of liquid. So this resultant force P is acting at the point C at distance h star from free surface of the liquid as shown in figure. So here we can see this is the point P at which the total pressure force is acting, and it is at a distance h star. Okay. Hence, moment of force P about free surface of the liquid, capital M is equal to P into h star. So this is the resultant. Okay. Capital P is the resultant force, and its moment will be capital P into h star. Now, if we consider the small strip, number of strips there, and प्रत्येकाचा मोमेंट जर आपण या ठिकाणी कन्सिडर केला, then we can do the integration of that and we can equate the moment of force dp. dp is the small force acting on the strip. Similarly, dp1, dp2, dp3 असे वेगवेगळे number of total pressure forces we can find, and we can do the addition of this all moment of the components, okay, moment of the forces, and we can do the integration of that. Moment of force dp acting on strip about the free surface of the liquid, dm is equal to dp into h. Therefore, equation 1, dp from equation 1, dp is equal to, we can write here gamma. This is the equation 1, okay, that we have written dp is equal to gamma h dA. Then dm is equal to, instead of this dp, I can write now this gamma h dA here, and this h already. Network connection was lost. So here, instead of this dp into h, we have now put, instead of this dp, we have put this value here, here, and we got this equation. Now it can be converted as gamma h square into dA. Okay. Now sum of the moment of all such pressure forces on strip about the free liquid surface is obtained by integration. Integrating equation number 4. ही लास्टची इक्वेशन आहे, त्या इक्वेशनचं इंटिग्रेशन आपण केलं तर आपल्याला काय भेटेल, we'll get the sum of the moment of the this component. That's why we have done the integration on both sides here. I have taken this gamma on outside the integration sign. Here I got gamma into integration h square into dA. Okay, but this integration h square dA is nothing but it is the second moment of inertia, or we can call it as a second moment of force, or we can call it as a moment of inertia about the free surface. Okay, I0 about that horizontal axis. So instead of this writing this integration h square dA, I can write here I0. Okay, this will become gamma, and instead of this I will write I0, and this is our equation number 5. Now if you see there in the equation number 3 here, there is capital M is equal to P into H star. This is equation number 3, and this is equation number 5. Here also M is there. So now we can equate this right hand side of the both equation. P H star is equal to gamma H0. Okay, I0. Now again here another principle we have to apply, that is parallel axis theorem that you might have studied in the solid mechanics or structural mechanics. That is given by equation I0 is equal to Iz plus A h bar square. So what is the meaning of this? Suppose there is one object and there is a horizontal line is there. About this axis, if you want to find out what is the moment of this object, right? Then we can write this I0 is equal to Ig. Ig is nothing but it is the moment of inertia at the centroidal axis. Okay, this is the centroidal axis Ig plus this distance into uh, cross section area of this particular object. So that is nothing but ah bar. So instead of this I0, I can put Ig plus ah bar here, and after putting this there, I will get here, uh, I will cancel this gamma, h star will be equal to, I will take this thing here on the right hand side, so it will go in the denominator here also and here also. Now this it will get cancelled here, and I will get here, so square is here in the numerator, so one it will get cancelled, and that can a cut होऊन जाईल, एक h आणि ह्यातला एक h cut होऊन जाईल, h star I will get, h I will get here as bar, and हा part as it is या ठिकाणी लिहिलेला आहे. So the final equation for this I get here as h star is equal to Ig upon ah bar plus h bar. From this above equation, equation number 7, it is clear that Cp always lies below the Cg. So the MCQ question may come in your examination that center of pressure always lies below by Cg. Cg is nothing but this distance. याच्यापेक्षा हा खाली असतो कितीने, तर एवढ्या क्वांटिटीने तो खाली असतो. Okay. For greater depth, Cp approaches Cg as h star h bar is larger. तसं डेप्थ वाढत जाईल तसं सीजी आणि सीपी मधलं अंतर हे कमी व्हायला लागतं, म्हणजे एच स्टार आणि एच बार मधलं अंतर कमी व्हायला लागतं. कारण जर तुम्ही पाहिलं तर ही खालची डिनॉमिनेटर मधली व्हॅल्यू वाढत जाईल, म्हणजे ह्याची व्हॅल्यू कमी होत जाईल. ठीक आहे, तर ह्या दोन्ही मधलं जास्त अंतर त्या ठिकाणी राहणार नाही, कमी कमी होत जाईल. सो this was the derivation for total pressure force acting on the vertical surface. Okay, plane surface submerged in the liquid. So here, have you given the MCQ test 1? Have I given you the MCQ test 1 to your class? तुमच्या क्लासला मी MCQ टेस्ट दिलेली आहे का आधी?
No, sir.
No, sir.
Okay, now we will stop here. I will take your attendance, and I will share the link on your WhatsApp group regarding the MCQ test. Okay. So wait here. I will take your attendance first, and then you can leave the session. I am unable to speak loudly, so you may not be hear my voice. That's why I am stopping here. Okay, I have taken your attendance. I will share the link. I have sent the link. Please tell me whether it is opening or not. Check it.
हो सर ओपन होते.
Okay, so you can attend the test and submit that paper. So now here we can leave the session. I will end this session here.